All right, so here we are continuing on page 12, looking at some examples where we are factoring completely. So that means we need to find the GCF and factor that out first. On this one, all of them are negative, so it's nice if I pull that out. Remember that any other GCF that you could pull out would have to be in all three terms. So there isn't anything else that I could pull out of this one. So you can leave the negative one there, or put it over in your answer blank and off to the side, and don't forget about it. So then I am looking at how to factor this. And that means my t table is going to be for my constant of 35. So looking at 35, so 1 and 35, or 5 and 7. So those are the only possibilities. This is one where you might have gotten away with not making a t-table for it because there's so few factor pairs for 35. So yeah, we know 5 and 7 would add together to be 12. And we know that they are either both addition or both subtraction because we have a positive constant term. So we are looking at y plus something, or y minus something, y minus something. And 5 and 7 are the ones that we're going to be looking at. So 5 and 7, 5 and 7. All right, and again, this one is all addition, so we can't get any subtractions, and if we have subtractions in our binomials, there's no way we can get all positive values in our trinomial. So that means that by process of elimination, this one's got to be the proper one. Double check by foiling, so y squared plus 7y plus 5y plus 35. Add those middle terms together, and you will get back to that original one. Now remember, that wasn't the actual original one printed in the notes. We need to not forget that GCF of -1 that we had pulled out previously. So in my final answer, I'm going to have a -1 out front, or just the negative sign out front, and then those two binomials, y plus 5 and y plus 7. Now let's look at a GCF that is a little different. So let's look at okay, so let's look at actually the third one on the top row. So that is going to be 22t plus t squared plus 72. So when it says factor completely, there may be a GCF, there may not be a GCF, but you do need to get in the habit of checking for it, and also get in the habit of putting these in descending order. So I'm going to first put my squared term, then I will put the t term, and then the constant. Now if I look through those, there isn't going to be any GCF other than +1, so there's nothing I can factor out there. So I go right to saying, all right, well, 72 is my constant, so that's the one I'm going to find with my t-table. So 1 and 72, 2 and 36, 3 and, what is that going to be, 24. And remember, you do have a calculator available. You don't have to do this all mentally. Just make sure that if you divide 72 by 3, that you're going to get a whole number answer there. All right, 4 and 18, 5 doesn't work. 6 and 12, 7 does not work, and then we get 8 and 9, and then there are no factors in between there, so I would just start repeating if I kept going at that point. So looking at those, you've got to figure out which pair is going to add or subtract to 22. Now we know that it's either both addition or both subtraction, because we have a positive constant term. But notice that you've got everything positive. So, and that's really going to end up having to be limited to both being addition. So we're looking for, when I add the two factors together, that we're going to get 22. So if you added 1 and 72, of course, that's going to be 73. This one would be 38. This one would be 27. This one would be 22, 18, and 17. And the reason I'm just looking at the addition is because I have addition with everything. And that's just, it's limiting what possibilities I have. So then the one that's going to add to 22 would be the 4 and the 8. I know that they are both addition. 4 and 18, pardon me. And that means that this should be my answer. Again, it's always a good idea to FOIL it out and make sure that you are correct. So t squared plus 18t plus 4t plus 72, these two will add to 22t in the center there. And then that would be the final answer on that. And again, you could interchange those completely. So the first binomial could be the t plus 18, and the second binomial could be the t plus 4. That won't change the final answer there. You'll still get that middle term being 22t, and then the other two terms being the t squared and the 72. All right, let's look at... we'll look at the one on the bottom right of page 12 here. So we're still on page 12. And we're going to look at x cubed y cubed minus 19x squared y cubed plus 60x y cubed. So it's a good idea, remember, to have it in descending order first. Remember we learned on our last test that you got to add those powers to get the degree of the term. So this one is the 6th degree, this one is 5th, and this one is 4th. So it is in descending order. The highest exponent term here, then this next, and then the lowest. So it is in descending order, and we want to look and see what's common to all of the terms. So x cubed, x squared, and x. Okay, so we can take out the smallest. So we can pull out an x to the first power. And then we have y cubed, and y cubed. So we can pull out a y cubed. And then if you look at the coefficients, we've got 1, 19, and 60. So nothing common there. All right, so inside the parentheses, once we have pulled out the xy cubed, so we would leave behind an x squared, then minus 19x and plus 60. So it looks really complicated until we factor out that GCF. So always check for the GCF. And especially if it is looking like it is going to be more complicated than another, a typical trinomial. So once we've done that, then, this is a lot easier to deal with. We don't have a coefficient other than 1, so we're going to take 60. 60 would be the one that we are going to factor. So we will do our t-table with 60. And see what multiplies to 60 but adds or subtracts to 19. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. So we do have a subtraction in there, so we may be adding or subtracting to get to our middle term there. So let's see, 61 or 59. This pair would give us 32 or 28. This pair gives us either 23 or 17. This one would give us 19 or 11. This pair gives us 17 or 7. And then this pair gives us 16 or 4. So only one of those ended up having a 19, so that would be the 4 and 15, which, is going to make sense because we've got the addition there, so we know that they're either going to be both addition or both subtraction. Since our middle term is negative, we're thinking it's probably going to be both subtraction there. So I am looking for something like this, and then filling in those two spots there with the numbers from my t-table, so that's where we'll pull in the 4 and the 15. And if you're checking, remember, just check the binomials to make sure that those get back to the trinomial you have here. So we would get x squared minus 15x minus 4x. So that would give us the negative 19x, and then negative 4 times negative 15 would give us the positive 60. So to clean up my answer there a little bit then, so it'd be xy cubed, pardon me, as the GCF out front, x minus 4, x minus 15. You can change the order of these. Generally, though, we are always going to put any monomial factors out front and then the binomial factors. But these two binomial factors could be interchanged. And if you multiply all that stuff back through, you should get back to that x cubed thing that we started with, the x cubed y cubed trinomial. Okay. Let's see. Okay, I have tons of extra examples on here just to make sure that you're having a chance to look at lots of different things. So we're not going to do all of them. Let's hit one more, though. Let's do the 5w to the 4th term. Okay, so for that one, if I'm looking for a common factor, and this one kind of screams out at you because you've got a bunch of multiples of 5 there. So you do have 5 that we can pull out. And then also we have w squared that we can pull out of that. So leaving behind a w squared, because what times 5w squared would give me 5w to the 4th, we've got to have a w squared there to make that multiplication work and when I'm going backwards. And then what times 5w squared gives me 35w cubed, so that would leave behind a 7w. And then what times 5w squared would give me 50w squared, so plus 10. So the GCF is out. Now we got to check and see if that trinomial is factorable. So we're going to look at that constant. So 10, so 1 and 10, or 2 and 5. So 2 and 5, right, are going to be the ones that are going to add to that middle term to get the 7. And we know that they are both addition or both subtraction because it's a positive constant. And then because the center is negative, they've got to both be subtraction. So, if you're not seeing that just yet, then we will, I will write down the two possibilities that we have. So it's either this or 5w squared, w plus 2, w plus 5. But you can see that this one will not give us a negative middle term because it's a bunch of positive things multiplied together. So that will knock this possibility out, leaving us with this one. And this will multiply back to this trinomial. If you multiply this GCF back through that trinomial, you should get back to the original one. So the final answer for that one is this. And again, you can interchange those binomials. Those can switch, and we do typically put the GCF, the monomial GCF, out front so that everybody can see it easily. Okay, so we've looked at several there on page 12. And let's look at quickly at this one on the bottom of page 13 before this video has to upload, and then I can take care of that. So a student factored a trinomial, and this was the factored form they had was 2x minus 4 and x minus 3. The instructor did not give full credit. Why? All right, so here's where you need to look back at those binomials and double check. Is there a greatest common factor that was not factored out to begin with? And if you look at this one, hey, they're both even. So I could have factored this further to 2 times the binomial x minus 2, and then, of course, the x minus 3. So it was not factored completely. There was a GCF there on that initial term. In the initial binomial.